All right, guys. So I decided to make a tutorial because due to these holidays and some restriction of time, a limitation of time, we don't have much time to make problem solving sessions. So I decided to make some tutorials share with you. So it will be helpful, guys. And so what we'll do, I will solve these past paper problems. But first, let's little bit discuss about IGCSE. In IGCSE, you all know, but just not worthy, right? To remind, IGCSE, guys, it has three subjects, right? So let's say the biology one, and then it comes chemistry, then the physics one, right? So, but they all will have on the same paper, right? So you will have IGCSE, so three papers at the same time, right? The exam consists of three papers. So first will be multiple choice, MCQ. So MCQ contains 40 questions, guys. 40 questions, and 40 divided into three parts, right? So let's say 30, 30, 14, 13, 13, 14, maybe. So this range actually, okay? So the questions, so maybe 13 biology, 13 chemistry, 14, let's say, that one, physics questions, okay? So they will come in order actually. So MCQ. Similar for structure part and practice as well, okay? Practice also have three experiments for these guys. But what you will do, for now, let's talk about MCQ only, okay? So this paper is MCQ. So MCQ is 22 paper question paper 22 for our school, and question paper 42 for the structure one, the solution, and question paper 62 for the experiment part actually, okay? Uh, all right, so I will solve, guys, maybe two, maybe three, let's say three past paper that ones related to physics, only physics questions. Then I will do mock examination. The questions will be only relating to physics, okay, guys? Now, by the way, am I the sound? Is it sound there? Okay, good. All right, no problem. Now, all right, let's go. Let's get started. So I just say the MCQ. It's you are given only 45 minutes, okay, and the mock exam will be same 45 minutes. So there are 40 questions. So each question will have 1 point. So each correct answer will score 1 mark. The mark will not be deducted for wrong answers, okay? So let's get started. First question, see, living things, so biology, I guess. So biology, 8, which cells, biology, right? Former, genetic, I don't know, biology, I guess. Correct statement, what is that? Fox, mouse, all biology, I guess. See, 12 question, biology. This is also fertilizer, I don't know, probably biology. Nucleus is correct. About atom and nucleus, probably starting from 14 is chemistry now, I guess. Chemistry, I don't know, aluminum chemistry. Which metal is make chemistry? Maybe around 26 chemistry, right? So even 27, it's alkynes chemistry. 28 density. Okay, let's starting from 28. We have what the physics. So let's get started with questions. Okay, 28. Starting from 28. The metal has density of 20 gram per centimeter cube. The bar made of this metal volume of 50 centimeter cube. What is the mass of the bar? Well, density would be, guys, what? Mass over volume. And density is given, so 20 gram per centimeter cube. Okay, centimeter cube. And this also centimeter cube, so you don't need to convert anything here. So the mass being asked, mass over volume would be what? 50 centimeter cube, right? So mass would be 20 gram per centimeter cube times 50 centimeter cube cancelled. So you have gram left only. So 20 times 50, 2 times 5, 10, 2 zeros, 10, 1, 2, 1,000, right? So 1,000 gram. All right, so it's going to be D. So 28 is D. 29. The object of mass m moving with speed v has kinetic energy E. Okay. The second object, also of mass m, moves with speed v over 2. Okay. What is the kinetic energy of the second object in terms of E, I guess? Yes. There are two objects. So first one is moving with v. It has m and it's moving with v. All right. So kinetic energy would be what? Kinetic energy would be kinetic energy. The formula, if you remember, guys, kinetic energy equals 1 over 2 mv squared, right? So in this case, it would be 1 over 2 m of first particle velocity of first particle squared. So simply 1 over 2 mv squared, right? So, and this is E, of course. Of course, this is E. Second object, it's also m, I guess. The second object is also m, but it's going with slower, so v over 2. So kinetic energy of the second guy would be 1 over 2 m of 2 velocity of second guy squared. So 1 over 2 m is same mass, velocity v over 2 squared, right? So this would be what, guys? 1 over 2 m v squared over 4, right? So this will be simply mv squared over 8. All right, so let's go back to first particle. It was what? If you paraphrase this one, E would be, guys, mv squared over 2, right? So simply E would be what? mv squared over 2. So take this, the second object, that one. So mv squared over 2 times 8, let's say, right? So can we write as this? mv squared over 2 times 1 over 8, 1 over 4. Yes, we can. And this is E, right? So we know that this is E. So this would be E times 1 over 4, simply E over 4, right? Do we have it? Of course we do. And it's 8. 30. Which energy resource does not have the sun as its source of energy? Now, dear friends, sun so sun doesn't have three energies, actually. Okay, in our book stated 3 energies. Probably, I mean, you have seen this one in previous year with your other teacher, I guess. But anyway, so sun doesn't have some forms of energy does not come from sun. Okay, they are what? They are geothermal. So it's magma, right? The lava underground. So let's say in earth, guys, the lava called magma. So once it goes out, it called lava. Melting rock, okay, it's called magma. So geothermal, it's the source, it's magma, actually. Then nuclear, okay, this comes from elements which make up a small portion of earth crust, right? So nuclear energy also not it's not from sun and the tidal, okay? So the revision, so this comes mainly from the gravitational attraction of moon, right? So this all does not come from what? From sun. So which one is here? So geothermal, simply, right? Right. 31. Hot water tank is fitted with 2 identical heater P and Q. Heater P is fit above the heater Q. Okay, so we have tank. So this is going to be the heater of Q, and this is P. P is above the Q. Okay. The tank is full of cold water. It's cold at the beginning, so they are switched off. They are not on yet. So when only heater Q is switched on, it takes long time to heat the tank of water to 60 Celsius. So if you switch Q, it will take long time. When only Q, so P is not switched. So it takes long time to heat the tank of water 60 Celsius. Okay. What happens to the cold water when only heater P is switched on? So what happens to the cold water when only heater P is switched on? Okay, all water reach 60 Celsius in less time. No, it's not, guys. Please keep in your mind, guys. So when water heated up, okay, molecules move up actually, okay. So it will move up, it will get hot here, then it will go down here. Meanwhile, it will observe also some energy, the upper one. So basically, if heater Q been if there are two tanks, heater Q and heater P, if you compare them, heater Q will heat up the tank faster, not so P will take longer time. I mean, okay, this is wrong. All the water reach 60 cells in the same time. No, 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 in this, not in the same. As I said, heater Q will warm up the water in the tank faster. The water below heater P reach 60 cells in less time. No, no. The water above heater P reaches, yes, in less time. So first, guys, first, as I said, first the above one, because hot water moves up. So first here reaches, then this time reaches. As we see the volume here, volume 1 and volume 2, volume 1 is less than volume 2. So time taken to heat up the T1 or the volume 1, okay, T1 is less than T2, okay. It's less, okay. Actually, the water below heater P reaches no, below more, but above is less, okay. D is correct. The maximum distance a particle on the surface of deep water moves from its rest position when wave passes it. The maximum distance a particle on the surface of water, on the surface of deep water, moves from its rest position when wave passes it. Which property of the wave does this describe? Okay, so it's steady up at the beginning. Okay, imagine it's the blue color. Okay, let's say at the beginning it's this one. Okay, so at the beginning it's this one. Okay, well it's steady. So imagine it's this one. Okay, so once the wave come, guys, once the wave come, which one will describe that one? So amplitude, right? It's going down and up. Not frequency or speed. The particles go up and down. Not water move, but the energy moved as a wave, but not the particles. Particles stay there, right? Particles stay there. So simply the amplitude, I would say. All right. So it's A. The diagram shows light passing through the plastic block. What is the refractive index of plastic block? Well, do you remember refractive index would be sine incident, okay, incident angle incident, over sine angle of refractive. So we are looking for the plastic one. So what we would do, well, the plastic one would be this is incident, right? And this is the refractive. So this is the refractive line, and this is the incident line. So n would be, guys, what? Sine. The angle would be 55 over sine 40. Well, calculator is allowed, so let's use calculator here. So sine 55 divided by sine what? 40, right? So this would be 127. Okay, 1.2743. So simply 1.27, 2 digits, I guess. This would be, and that's what that would be C. Okay. One minute. All right. Well, here, guys, there would be what? There would be a nicer that one, guys, basically. There's a formula also during the class. I told you, I guess. Well, it's safe to use this formula, no problem. But I would suggest, guys, suggest sometimes it may be wrong. Okay, sometimes. So it's always safe to use this one, guys. So an incident, okay. So an incident, because this is air, guys. So air would have one, so you will neglect it as one. That's why it works here. But if you do it opposite, it may not work. Okay, sometimes it's rather than, so it may be glass and plastic. In this case, it may be problem. Okay, so it's always safe to use this way. So n incident equals to, n incident times sine incident. Okay, sine theta incident equals to n refractive sine theta refractive. It's always that one. Safe to use this one, guys. Okay. It's always safe to use this one. In this case, n of air we always choose as 1. Okay. N air is 1. Okay. That's why we just neglect it. Okay. You can use this one as well, but if you wish, this is also safe. Not problem. Okay. We can derive this one from this formula. Actually, we can. But anyway, so skip it. 34. Which ray diagram represents the formation of virtual image of object? Well, maybe we didn't study about this. We studied actually, but as a review purpose, okay. And this would be very quick, guys. So and noteworthy point actually, okay. Well, in what is that? Forming image, guys. There are 3 cases, okay. Imagine we have lens, okay, lens. Now this would be your focal point, okay, and this would be 2f. Now, if guys, first case, there are 3 cases. If your object between, so if your object between 2f and f, let's say your object is here, okay, your glass is here. Your that one will be, let's say it goes here. Your object will be what? Your object would be not this way, but around here. All right. So your object will be bigger. Okay, it's real image, a real image, and bigger image. Okay, bigger image. Okay. So if it's between 2f and f, so it will be real image and bigger image. Second case, when your object beyond 2f. Okay. So here you have this is 2f and this is the focal point f. If your object here beyond 2f, your image will be a real image but small. Okay, it will be here, it will go this way, maybe this way and this way. Okay, so here, okay, this is also real image, but small. Okay, smaller than the real the image itself. Third case would be, guys, exactly on 2f. Okay, so here f and here 2f, it's exactly on 2f. It will be, guys, it would be, let's say, I don't know, it goes this way and it goes this way. It will be exactly same. Okay, this also real image, and it's what? Same size, of course inverted. Okay, these 3 are inverted. And the fourth one, guys, the fourth case would be when object is between lens and f. Okay, between lens and f. Here we have a lens, here's 2, here is the f, and here's 2f. If your object is between lens and f, your object will be, guys, what? Your object will be, okay, it goes this way, but it goes back, and I don't know, here and here. Okay, it will be big. All right, but it will be virtual. Okay, it will be virtual. In here it's virtual. Virtual. Okay, virtual image. Okay, the first case would be virtual, and it's what? Of course, bigger size. Okay. So which diagram represents the formation of virtual image? It would be which one? Of course, A, right? So this would be real image. This, no, there's not such a case. There's no such a case, but it will be virtual. It would be A. 35. 2 unmagnetized iron nails are in contact with the S pole of the permanent magnet. The heads of the nails X and Y repel each other. Okay, as we see, they are repelling because they have same poles. Why? Guys, this will be all S poles. Okay, this would be all S pole. That's why they repel. So why do X and Y repel? X becomes the N pole, Y becomes south pole. No, no. X becomes this. No. The X and both become N poles. X and Y both become south poles. They both become south poles. That's why. All right. And it's 35 is D. All right. Which graph current voltage diagram of filament lamp? Remember filament, they don't obey the Ohm's law. Ohm's law. What is Ohm's law, guys? Ohm's law, and the current I and the voltage, it's this way. The filament lamp, it follows in what still one point, then it will say, hey, the current stays same as the voltage increases, current stays same, right? So it will go this way if you remember. It's C. It's C here, right? So this is Ohm's law. This is no such a case. This is a fuse actually. The current voltage goes same, but the current is voltage increases, current same. There's filament lamp, but this is, I don't know what is. There is no such thing, I guess. There is a current of 100 mega ampere in the circuit. How much charge flowed through the circuit in 1.5 minutes? Well, current is, guys, current, the definition of current is what? The charge per time, right? So Q over time. Well, the current is given. So current is 100 mega ampere, the 10 to the power negative 3, equals to Q being asked, charge being asked. It's Coulomb, okay? Time is 1.5 minutes, 1.5 minutes. It should be in seconds, right? So 100 times 10 to the power negative 3 ampere. Q over 1.5 times 60. So Q would be, if you use 100 times 10 to the power negative 3, simple 0.1 times 1.5 times 6, right? It would be 9 Coulomb. 9 Coulomb. All right? Do have yes, it's B. All right. The fuse is safety device for using the alternate electrical circuit. The current in the circuit becomes greater than the rated value for the fuse. If it's greater than the fuse, it will burn. It will not work. It will not allow any current. What happens? Okay, the function of the current fuse is what, guys? To prevent high current pass into the device, which may what is that? Harm it, right? So if it increases, guys, 1 minute. If it increases, so if it increases, it goes beyond the fuse's capacity. Fuse will burn, so it will not allow any current to pass in. So the current decreases to 0. Even A, the current decreases to 0. The current decreases to rated value of fuse. No, it will burn. The thickness of the insulating around the wires increases. No. The current is sent to the other case. No, not other applies. So it's decreased to 0, definitely. 8. Okay, 2 questions left. What is the purpose of the slip rings in alternating current AC generator? To allow each end of the coil to contact each carbon brush alternatively. What is the purpose of the slip rings in the alternating current? Well, we didn't study this one, but we'll study in the next week's class, actually. All right, so this is amateur, right? So then we have what? Slip rings. Remember slip? I mean, of course, you didn't study yet. So magnet here, this is the inside motor, okay? So what they will do when they rotate, guys, actually, when they rotate, this is called amateur, okay? This is called amateur, simply. When they rotate, the voltage will increase. In AC, guys, this is direct circuit. This is simple circuit. So the battery, okay, leaves the lamp, turns on, it comes back, okay? So plus sign, let's say, so it goes this way, it comes back. This is AC. But in this is DC, girls, direct circuit. But in AC, guys, alternating current, let's say direct current or alternating. Alternating is changing, okay? The voltage increase, the voltage changes, okay? It becomes negative, positive, actually, okay? So here, voltage is always plus, okay? But here, in motor, guys, it changes due to the magnetic change, okay? So because magnetic south and north poles, let's say, when it rotates, guys, it will change, okay? 180 degrees plus other 180 other parts from 180 to 360, it will be minus. So imagine, guys, your house, you always having plus minus volts. It's not the case, okay? What they do, they put these slip rings to change the current, actually, okay? When it's 180 plus, once it's 181, so when it changed to minus, they will convert and they will make it plus again. So what they will do, actually, to allow each end of the coil to contact the carbon brush alternatingly, no, to allow each end of the coil to remain in contact with the same carbon brush all the time. Yes, exactly. So they will do what? Slip rings. There's two slip rings, okay? So one will collect from this side, one will collect from the other side. So it will do what? So once it rotated, so this will touch into the slip ring, the left one. The right one will touch to the second slip ring. Okay, it's called slip ring. Slip. So once this is plus, let's say, and this is minus, let's say, this plus and this minus, let's say, okay? So plus will be connected to this. After it passes from 181 to 360, it will not touch to the brushes. They have brushes here, okay? So it will keep contact with the, there will be carbon brush. Here will be carbon brush, okay, brush. So it will always keep contact with the slip rings, this one, okay, actually. Then you will have other stuffs to alternate, so to change it, okay? But the main purpose of the purpose of the slip rings, guys, to remain in contact with the same carbon brush all the time, okay? 40. So the diagram represents the nuclei of 4 different atoms, V, W, X, and Y. Which two diagram represents isotopes of the same element? Right now, atomic physics, okay? In isotopes, what is isotopes? Isotopes. You studied from chemistry as well, I guess. But anyway, so isotopes, guys, in nature, same element. For example, hydrogen. Okay, 1 1. There's hydrogen 1 2 as well. Okay, there's a hydrogen 1 3 as well. Okay, but they are not stable. They are not stable. Stable. So same element may have different forms of itself. So others will be not stable, so they will react with some kind of reactions, okay, with nature. Then they will become stable, okay? They are unstable. So, but they are called isotopes. So why? Because if they have same proton number, they are called isotopes, right? So the upper one would be so this one would be atomic number, and this would be proton number. So isotopes are the elements with what? Same proton number. Okay, that's what called isotopes. So we have to find the same proton number. So here proton number is 4, here proton number is 3, proton number is 2, proton number is 2. Okay, X and Y. Which one? No, X and Y, no. C, X and Y. Okay, not this one. So it's going to be C. All right, so it was very easy. So okay, we finish here, guys. I will come with the other. This is 2018, I guess. 2018. We will go to the beginning of it. Okay, just go to the beginning. I don't know why. Okay, here. So even the late one, right? So June 2020. Not 18, but 20. So I will come with 19. There are two. So it's spring one and that one, the winter one, the November, and the spring or the summer one, May or June one. Okay. So I'll come with it.